So this video is a direct carry on from the previous video where I didn't do any examples. This video is going to only have examples. So they're examples of the confidence intervals and the margin of error. So example 1, what sample size is needed to have the following margin of error? So we have the margin of error. We want to know what population size or what size of the sample do we need to get that size margin of error. Now, I've already told you that the margin of error formula is 1 over n squared. That's how you get it for now. There is more complicated ones in a minute, but this is the easiest one for now. So we know that the margin of error is 5%. So in general, we don't usually want a percentage in our equation because that complicates things smaller. So I'm going to convert this to a decimal. So 5% is 0.05. And I'm looking for the sample size that would give me a margin of error of 0.05. So basically, it's now gone from a inferential stats and information question to a basic, you can't see that side, a basic algebra question. 1 over the square root of n equals 0.5 or 0.05. So you can now see why it's so important to have such a strong basis of algebra, because every single section links back to that. So anyway, we're trying to find out what n is. So I'm going to do just cross multiply. So you get 1 equals 0.05 times the square root of n. Now I'm going to divide by 0.05 to get root n on its own. So we get 1 over 0.05 equals the square root of n. And to get n on its own, because it's square root at the minute, we need to square both sides. So n equals 1 over 0.05 squared. And that gives me an answer of 0.05 squared, 400. Which is actually the same number that we had in the previous example, in the previous video. So we need a sample size of 400 people to get a margin of error of 5%. Now the second example, exact same thing with 0.25, or sorry, 2.5%, 0.025 as a decimal. So 1 over the square root of n equals 0.025. Just to skip this line, you can see I just swapped those two, so I can do the same here. So 1 over 0.025 equals square root of n. So n equals 1 over 0.025 squared. So that now gives me an example of 1600. So 1600. So if I want a more accurate margin of error, I need to ask more people. I need my sample space to be, or sorry, my sample size to be bigger. And the last one, you can nearly guess, that's gone to 400. That's 1600, so it's gotten bigger. 1% is going to be bigger again. So same thing. 1 over the square root of n equals 0.01, so 1% as a decimal. Swap both sides, so we get 1 over 0.01 equals the square root of n. Square both sides. N equals 1 over 0.01 squared. And again, just go back to your calculator. Because I didn't delete it, I can just change the numbers. 10,000. So if I wanted to have a certain bit of information and I wanted it to be very, 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 very accurate, 5% is a big enough bracket. Like that's, as in the last video, it's between 45% and 55%. But if you get 1% of a margin of error, that would mean if your, say, proportion is 50%, it would go down as far as 49 but up as far as 51, which is very, very accurate. But you need to have a lot of people involved to get that number. So this is an example of a confidence interval with a real life setting. So a company has designed a new drug for asthma. They've tested 400 people to see if they have any side effects, or see if any side effects have occurred. 136 people claimed to have side effects from the drug. So they're trying to see, is it better or worse than current drugs on the market? Construct a 95% confidence interval for the proportion that might experience side effects. So, the first thing I'm going to do is write down all the information that I have. N was 400, because there was 400 people in the study. There was 136 had side effects. So, SE for side effects. That was 136. Now, the formula that we had to work out the 95% confidence interval was as follows. It was P hat minus E is less than P less than P hat plus E. So, just to explain what this formula was again. P hat was the sample proportion, so the amount of people from the sample that were affected. E was the margin of error. P was the actual number. Actually, you know what? I'll write it on the side. It was in a previous video. So just in case someone hasn't seen that. If you haven't seen it, go back and just have a quick look of it. You'll understand what all this means. So P hat was the sample proportion. P was the actual proportion. And E was the margin of error. Okay, so the sample proportion is 136 out of 400. So 136 out of 400. Now, preferably we want that as a decimal, so don't even try to work it out. Go into the calculator. 136 divided by 400 is 0.34 or 34%. So that is P hat. We don't know what P is. We won't find what that is either. The other example that we need now is the E for margin of error. And that is 1 over the square root of N, which is 1 over the square root of the amount of people involved, 400. And as you remember from the previous examples, 1 over 400 worked out as 5%, or you could say 0.05. Okay, so now I've got my P hat value, I've got my E value, and I'm now going to put these two values into the formula. So we have 0.34 minus 0.05 is less than P, which is less than 0.34 plus 0.05. And if we work out these two numbers, that gives me a final result of 0.29 less than P less than 0.39. Now, what does this mean? This basically means that with the sample you have taken, so from 400 people, you've discovered that you feel, or the company feels, between 29% and 39%, so 0.29, 0.39, 29% or 39% will experience some side effects. Now, these type of numbers can decide whether a company goes forward with making a drug, whether they have to go back to the lab to recreate it, and so on and so on. This can happen. This example is fairly easy to do. The maths isn't very difficult, but it's the context that can be changed to make it totally different. So in this case, we have between 29% to 39% have side effects. And that is our 95% confidence interval. Okay, now one more example. So the last example in this video, a rental company wants to find the average rent price in Cork. In a survey of 1,600 households, 960 paid over €1,000 per month. Construct a 95% confidence interval to find a proportion that pay over 1,000. So we're not finding the actual average, we're just trying to find what proportion pay above a certain value. So again, we'll write down the formula. P hat minus E less than P hat plus E. Okay, so that's our formula, that's okay. First thing we need to write down is N, we need to find E, and we need to find P hat. N is the number surveyed. Again, all this is outlined in the previous video. For stock, just you can go back to that. N is the number of people surveyed, which was 1600. E is the margin of error. We don't know what that is yet, but we'll work it out. And P hat is the proportion. We know that there was 960 people out of 1600, so that is our proportion. 960 out of 1600. We always want to get it as a decimal, so 960 divided by 1600 gives us 3 over 5, which is 60%, 0.6. Now, we need to find what E is. E is equal to 1 over the square root of N. N is 1600, so 1 over the square root of 1600 gives us a value of, we worked it a while ago, so you should remember it, 1 over the square root of 1600, just to show it, is 1 over 40, 0.025, which is 2.5%. 2.5%, or we've mainly used the decimals 0.025. Now, we want to work our confidence interval from these numbers. Now that I have this number, I can fill it in up here. 0.025. My 95% confidence interval, so CI for confidence interval, will be P hat, so 0.6 minus this number, less than P, less than 0.6 plus 0.025, which gives us a value of 0.575, which is less than P, which is less than 0.6 plus 0.025 gives us a value of 0.625. So these are our numbers. Again, the maths itself here isn't difficult. It's very similar to the previous question, but the context is totally different. So it doesn't matter what they ask, it's all the same steps over and over again. It seems complicated originally at the start when you mention what you're talking about, but when you start doing the questions, it's not. So 0.575 is less than P is less than 0.625. This means that 57.5% to 62.5% of people pay over €1,000 per month. Okay, so I hope this video helps with understanding how to work out the basic confidence intervals, and we'll see you in the next video.